Hello guys, welcome to Apex Math. My name is Pino. In this video, we go through question 3 from the April 2025 N5 Mathematics question paper. Question 3.1, we are given the following cubic function, and 3.1.1, we determine the coordinates of the turning points. Suppose that we have the following cubic function. At the turning point, the gradient m is equals to 0. At both the turning points, the gradient is equals to 0, and the gradient is the first derivative. So the first derivative of a function represents the gradient of the function at every point. So we have our m equal the gradient equal the first derivative, and at the turning point the m is equals to 0. So we differentiate that f of x and equate it to 0, so the f prime of x will be equal to the derivative of the x cube, which is equal to 3x squared, and the derivative of the negative 2x is equal to negative 2, and the derivative of the 3 is equal to 0, and we equate this to 0. We equate it to 0 because the gradient at the turning point is equal to 0. We solve for x, and 3x squared minus 2 will be equals to 0. Our 3x squared, we move the 2 to the right, it will change sign to positive 2, and we divide both sides of the equation by 3, and the x squared will be equals to 2 divided by 3. Introducing the square root both sides of the equation. When we introduce the square root on the right, we also introduce the plus or minus, and our x will be equals to positive the square root of 2 divided by 3, or our x will be equals to negative the square root of 2 divided by 3. We have to determine the corresponding y values by plugging the x values into this original equation, which we copy and paste. Where there is x, we are going to substitute these x values so that we can get the corresponding y values. So in the place of the x, we'll substitute the square root of 2 over 3. So we have the square root of 2 divided by 3 raised to the power 3 minus 2 multiplied by the square root of 2 divided by 3 plus 3. And for the other negative x value, the negative the square root of 2 divided by 3, the corresponding y value will be equals to negative the square root of 2 divided by 3 raised to the power 3 minus 2 multiplied by negative the square root of 2 divided by 3 plus 3. We have for the positive side, we have 1,911 as our y value, and for the negative side, we have 4,089 as our y value. When our x is equal to negative the square root of 2 divided by 3, the y value is 4,089. When the x value is equal to positive, the square root of 2 divided by 3, the corresponding y value is 1,911. And this will be the turning points of our cubic. 3.1.2, we draw up a table of x and f of x, where x is ranging from x is equal to -2 to x is equal to 2, and x is an element of integers. We just plug the integer value from -2 to +2. So let's start by plugging -2 where there is x, and f of -2 will be equals to -2 raised to the power 3 minus 2 multiplied by -2 plus 3, and f of -2, this will be equal -2 raised to the power 3 minus 2 plus 3, which is equal to -1. So when x is equal to -2, y is equal to -1. How about when x is equal to -1? In the place of the x, we substitute -1, and f of -1 will be equal to -1 raised to the power 3 minus 2 multiplied by -1 plus 3, and f of -1 will be equals to -1 plus 2 plus 3, which is equal to +4. And when x is equal to -1, y is 4. And when x is equal to 0, we have our y-intercept, which will be equal to 3. When x is equal to 1, we have f of 1 equal 1 raised to the power 3 minus 2 multiplied by 1 plus 3, and f of 1 will be equal to 1 minus 2 plus 3, which is equal to +2. And when x is equal to +2, we have our f of 2 equal +2 raised to the power 3 minus 2 multiplied by 2 plus 3, and our f of 2 will be equal to 2 raised to the power 3, which is 8, minus 2 times 2, which is 4, plus 3, which is equal to +7. We draw the following graph with the following points, and we also have the y-intercept, the 0 and 3. And we also have our turning points, our 2 turning points. So let's draw the graph. We start with our y-intercept. When x is equal to 0, y is equal to 3. So we have our y-intercept at 3, and when x is equal to -1, y is equal to 4. So we have -1 and 4. And when x is equal to -2, when x is equal to -2, y is equal to -1. So we have that -1. And when x is equal to +1, we have +2. We have 1 and 2. And when x is equal to 2, y is 7. Our 7 will be up there. So somewhere up, we have our coordinate 7. Our turning points, we start with the -1, -0,816, and 4. So we have it around 4,1 around there. and the positive 1, 0,816 and 1,9, 0,816 somewhere there, and 1,911 somewhere there. So we draw our graph, and we have our turning points, and there it continues. And I trust that you guys will put in the turning points, and we also have to label our y-intercept, the 0 and 3. Question 3.1.4, if x is equal to negative 1,75 is an approximate root of the equation x cubed minus 2x plus 3 is equals to 0, use Taylor's or Newton's method twice to determine a better approximation of this root, and we are to correct to 3 decimal figures. We are going to use the following formula, which is unfortunately not available in the formula sheet, and the x is equal to negative 1,75 will be our x1. So we have to determine x2 and x3. We name the x cubed minus 2x plus 3 as our f of x. Since we have the negative 1,75 as our x1, the n will be our 1. And when we substitute into that formula, x1 in the place of the n plus the 1 will be equals to x1 in the place of the n minus f of x1 divided by the derivative of the f of x1, and this will be equals to, so that 1 plus 1 in the subscript, 1 plus 1 is equals to 2, so we are determining x2, and x1 is that negative 1,75. We substitute that negative 1,75 into the f of x equation, and we take the answer, we plug it there, and we derive the f of x, substitute the negative 1,75 and plug the answer in the denominator where there is that f prime of x1. So let's substitute. We copy and paste the f of x equation, but we also have to differentiate the f of x. So the derivative of the f of x will be equals to the derivative of the x cubed, which is 3x squared. The derivative of the negative 2x is negative 2. The derivative of the positive 3 is 0. And now we substitute the negative 1,75, and f of negative 1,75 will be equals to negative 1,75 raised to the power 3 minus 2 multiplied by negative 1,75 plus 3, and this will be equal, so let's determine the other side. So the f prime of negative 1,75 will be equals to 3 multiplied by negative 1,75 raised to the power 2 minus 2. We have f prime of negative 1,75, and on the left we have f of negative 1,75, and this will be equal 1,141, and on the other side we have 7,188. Now we can substitute, so our x2 will be equal to x1. Our x1 was the negative 1,75. The x1 was that negative 1,75, minus f of x1. Our f of x1 we determined as equal the 1,141 divided by f prime of x1, which is 7,188. And our x2 will be equal negative 1,909. Now that we determine x2, we determine the x3. So from that formula, where there is n, we are going to substitute 2 for us to get to x3. So where there is n, we have x2 plus 1. x2 plus 1 will be equal to x2 minus f of x2 divided by f prime of x2. We follow the same process. We substituted x1 into the following two equations. Now we are going to substitute the x2. So we copy and paste so that we can substitute the x2 into the following two equations. Our f of x2, which was equals to negative 1,909. So we have negative 1,909 raised to the power 3 minus 2 multiplied by negative 1,909 plus 3, and this will be equal. So let's determine the other side. Let's substitute on the other side. We have f prime of x2 equal 3 multiplied by negative 1,909 raised to the power 2 minus 2, and our f prime of x2 will be equal 8,933, and our f of x2 will be equal a negative 0,139. We substitute into the equation, so the 2 plus 1 in the subscript will be x3. So our x3 will be equal x2, which was equal negative 1,909, negative 1,909 minus f of x2, which is negative 0,139, divided by f prime of x2, the 8,933, and our x3 will be equal negative 1,893, and this will be our answer. Question 3.2. The owner of a dog park has 120 meters of fencing and wants to create a rectangular area that is divided into 3 rectangular pens as shown in the diagram below. We have to find the dimensions of the rectangle that will yield the largest possible total area of the 3 pens and also determine this area. The 120 meters of fencing was used to fence around the total area and also to divide around the area into 3 pens. So we have y number 1 and y number 2 and y number 3, y number 4, y number 5, and y number 6. So 6 y's in total, plus x number 1 and x number 2 and x number 3 and x number 4. So 4x in total, and all of these should add up to 120 meters of the fencing. And we have to determine the largest possible total area of the 3 pens. So area is calculated as length times breadth. So we have y, which are 3, so we have 3y multiplied by 1x. We make x the subject of the formula in that equation, and 4x will be equal 120 minus 6y, dividing by 4 both sides of the equation. X will be equal 120 divided by 4, which is 30, and negative 6y divided by 4 will be equal to negative 3y divided by 2. We substitute the x into that formula for area, and our area will be equal 3y multiplied by, in the place of the x, we have 30 minus 3y divided by 2, and we distribute the 3y, and our a will be equal 3y multiplied by 30, which is equal to 90y, 3y multiplied by negative 3y over 2, which is 9y squared, divided by the 2. We have a quadratic equation in y, so our a will be equals to negative 9 divided by 2 multiplied by y squared plus 90y. So this is a parabola, so we have to draw the graph. So let's just draw the graph. We are looking for the maximum, the largest possible total area, the maximum area possible, and the dimensions for that. It will happen at the turning point. Either we differentiate, or we can use the formula y is equals to negative b divided by 2a to determine the turning point. So negative, where there is b, we substitute the 90. Where there is a, we substitute the negative 9 divided by 2, and our y will be equal, so that 2 and that 2 will cancel out. We'll be left with a negative 90 divided by negative 9. Negative 90 divided by negative 9 is equal to 10. Our y is equal to 10. What about the value of x, the corresponding value of x at a turning point? We copy and paste and substitute the 10 where there is y. X will be equal 30 minus 3 multiplied by, in the place of the y, we substitute 10 divided by 2. X will be equal, so 3 multiplied by 10 over 2 will be equal 15, and 30 minus 15 is equal to positive 15. Now let's determine our area. The area, originally we had area is equal to the 3y multiplied by x. We can use the other formulas which only have y. They will still give us the correct answer. So our a will be equal 3 multiplied by 10 in the place of the y, and 15 in the place of the x. and this will be equal 450 unit square, where we given any SI unit. Yes, our fencing was in meters, so we remove the U and we have meter square. Question 3.3, the radius of a circle is decreasing at a rate of 4 centimeters per second. How fast is the circumference of the circle changing when the radius is 8 centimeters? And the hint is that c is equal to 2 pi r, the circumference. Another hint is the how fast and the 4 centimeters per second, indicating that we have to differentiate the circumference with respect to time. The circle is decreasing and getting smaller, so we have the formula for circumference as c is equal 2 multiplied by pi multiplied by r. As the circle is getting smaller and smaller, the 2 and the pi will remain the same, but the circumference and the radius will decrease as this is decreasing with time. We differentiate with respect to time implicitly, so the derivative of the c will be 1 multiplied by dc divided by dt equal 2 pi multiplied by the derivative of the r is 1 multiplied by the dr divided by the dt. So we differentiate the circumference and the radius. The dc divided by the dt is the speed of the circumference, and dr divided by dt the speed of the radius. So the dc divided by the dt will be equals to 2 pi. Remember that we were given the speed of the radius. The speed at which the radius is decreasing was given as the 4 centimeters per second, with this being the rate at which the radius is decreasing. Remember that we used to say that when the velocity is increasing is positive and when it's decreasing is negative. Since the radius is decreasing, we have negative 4 centimeters per second, and the rate at which the circumference is changing with respect to time will be equals to 2 pi multiplied by negative 4, which is negative 8 pi, which will be equals to negative 25,133 centimeters per second. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content interesting.